Okay, good afternoon everyone. This is the last part of booklet 8 that I'm going to make a video on today. And in fact it's the last bit of content really from the lower sixth topics. So it's the last part of booklet 8 on diversity and variation, or variation and diversity. So if you're reading along at home, this is on page 7 in the notes booklets. And today we'll have a look at biodiversity and two of the measures of biodiversity. The first one is species richness. So I'll define species richness and species diversity. And species diversity is sometimes referred to as the index of diversity. And that species diversity, or the index of diversity, can be calculated. Now we'll compare species richness and species diversity and see why the index of diversity, or species diversity, is a more useful measure of biodiversity. Okay, once we've done that, we'll explain what impact humans have on biodiversity and explain why they have that impact. Okay, so to begin, some definitions. Biodiversity is just a general term that describes the variety in the living world. So the variety of species, it refers to the number and variety of different living organisms in a particular area. And there are two measures of that. Mentioned those already. The first is the species richness. Now the species richness is just the number of different species in a community. So a community are all of the species in a habitat or in an area. So species richness counts, essentially, counts those different species in the community. Just as a reminder, species is a group of organisms that can reproduce, what's going on there? Reproduce to make fertile, fertile offspring. Okay, so in a community there may be a number of different species, and if you count them up, count those number of different species, you have the species richness. Okay, so it's quite a straightforward way, a simple way of measuring the biodiversity of a habitat or an area. The index of diversity takes into account the number of individuals of each species, and therefore is considered more useful. So the index of diversity, or the species diversity, includes the species richness, so it's the number of different species, but also includes the number of individuals of each species. So it gives you an idea of the evenness of the number of species. And that's useful. Okay? That the number of individuals of each species is what we refer to as a population. So, when we consider what's going on here with my pen? When we consider the index of diversity, we consider the species richness and also the population size. You might think, why is that so much more useful? Well, in certain circumstances, in certain habitats or areas, you may find that there are the same number of species. And in fact, in this example, and this example is in the notes, we have 5 different species, okay, A, B, C, D, and E. The species richness, therefore, for both of these habitats is 5. Okay, it is the same. So if you were to compare them, you might think, well, the biodiversity of those 2 habitats is exactly the same. But in fact, if we compare habitat X with habitat Y, we can see habitat X has a real even distribution of all of those different species, whereas Y has a really uneven number. Okay, it's got loads of species D, but A, B, C, and E are all in relatively low numbers. There's an uneven spread of those species. So if we were to consider the richness, well, they would be the same. But we can use the index of diversity to give a measure of the richness combined with the number of each individual species, the population. So how do we do that then? We need to use this formula. D is the index of diversity, or the species diversity index, diversity number. Okay, sometimes this is called the Simpson's diversity index, but I think in most cases, in your notes and in textbooks for A level, you'll see it as just the index of diversity. Okay, on the top here, we have capital N, which is the total number of organisms of all species. Okay, multiplied by n minus 1. That is divided by the sum of, so this symbol here, sigma, means the sum of, so you're going to add up the total number of individuals of each species, so the populations of each species, multiplied by little n, population of each species, minus 1. This gives us a calculation or a value of D. And the larger that value of D, the greater the species diversity is in that habitat. And therefore you can then compare the different habitats. Larger numbers shows that one habitat is more diverse than another. So how do we calculate that then? Okay, so you've got this table in your notes. It's back to the one that we looked at earlier on. So we can see here the numbers found. Let's start down here. The number of individuals, so the total number of individuals. Well, there are 10 of each of these species in habitat X, so the total number, or capital N, is 50. And in fact, in habitat Y, that is 50 as well. To calculate that, the bottom line here, the sum of the total number of individuals of each species, multiplied by that number minus 1. Here we would have 10 times 10 minus, oops, it's not 10 minus 9, sorry, 10 minus 1, okay, which is 90. Then it would be 90 for all of those. For habitat Y, that would be 3 times 3 minus 1. Multiply 3 minus 1, etc. Okay. Then we take a sum of these values for our calculation. So here we have it, and there we have it, all calculated. So the sum of lowercase n, so the total number of organisms of each species, multiplied by total number of organisms of each species minus 1, for habitat X is 450, and for habitat Y is 1300. Okay, so to finish off that calculation then, well, we know that capital N was 50 for both. We have it here. I think we've got it here. 50 for both, so 50 times, well, 50 minus 1, 50 multiplied by 50 minus 1, or 49 is 2450. Okay, 2450 divided by 450 gives us a measurement of value for the index of diversity in habitat X of 5.44. And in habitat Y, 2450 divided by 1300 gives us a value of 1.88. Therefore, habitat X has the higher species diversity, or higher value for the index of diversity, than habitat Y. And perhaps we could have predicted that at the start, because we can see there's an evenness to the distribution of species in habitat X, whereas habitat Y is dominated by this species D. Okay, let's have another look at another example. Okay, so these are petrels, seabird, and you've got this example also in your notes. Okay. So calculate an index of species diversity for each of those habitats. So habitats A, habitats B, and determine which has the greater diversity. So we're looking for the greater number of, greater value for D, index of diversity. So what we can find is, if we add up the total, or if we add up to find capital N, which is the total number of organisms of all of the species in habitat A, is 31, and all of the species in habitat B is 22. And then for A, the total number of organisms of each species multiplied by, well, n minus 1, in total is 176 in A, and then 232 in habitat B. That gives us, so 31 multiplied by 30 over 176 gives us a value of 5.28 for the index of diversity, whereas in habitat B, lower at 1.99. Okay, so in this question, determine which habitat has a greater diversity. You would need to show your working for this. Okay, it's unlikely that you'd be provided with the formula to calculate that, so you need to remember that formula. But you would need to show your working by drawing a table similar to this and calculate the values for capital N, so as we've got here, the total number of organisms of all of the species, and then the sum of all of the lowercase n's, the total number of organisms of each species. Okay. Now, in this question, explain why it is more useful to calculate species diversity index than just to record the number of species present. Well, that goes back to what we said. Where was it? Okay, what we said here. So it takes into account the number of different species and the number of individuals of each species, and therefore gives us a better understanding of the evenness of the species present. Okay, so that's everything for index of diversity. There are some other examples I'm sure your teachers will expect you to complete at the end of this booklet, but I'm not going to do that now. I don't want to give away all of the fun there. Okay, so other things that we might be expected to do with biodiversity is interpret the species diversity data. Now, this is a sketch graph showing over time, so time on the x-axis, the effect of environmental change. Okay, so over time there is environmental change, and we want to see what effect that has on these two communities. Okay, so the red line shows the community with a high species diversity. So remember, species diversity includes the number of different species, but also the number of individuals within each different species. Okay, and this could include plants as well as animals. So it's all of the species in the community, not just necessarily animals. Okay, now the reason that's important is plants often provide a particular habitat. Okay, so in a community with high species diversity, it would be expected that there is a high diversity or a large number of species of plants. Sorry, I let my dog out. Sorry about that. And those plants, each of those plants, so there are lots of different species of plant, each one may be able to provide a different habitat. Each of those plants may be a different food source. So you've got lots of plants, you've got lots of habitats, and a greater range of food source. So communities with a high species diversity have a greater range of habitats and a greater range of food sources. The community with low species diversity, okay, may have fewer species of plants and therefore fewer habitats. If there are fewer habitats, well, perhaps that means that there are fewer insects living in those different habitats. Maybe each insect might require a specific plant as its habitat. Now, if you remove different species of plant, well, you remove the habitats for those insects. So you've removed the producers, the plants, then you remove the insects, the primary consumers, those herbivorous insects. Well, that means there is less food available for perhaps a secondary consumer, maybe a bird or a carnivorous insect like a ladybird. So by removing the plant, you reduce the range of habitats, you reduce the range of food sources, meaning it's less likely that the species will be able to survive any environmental change. Okay, so what we see here then, the grey line, well actually I'm going to highlight it now. Here. So there we go, here's the, this shows the environmental change. Now, that community with low species diversity, the purple line, let's see if I can make it a bit clearer. Okay, that purple line here, well, we can see it follows the pattern of the environmental change quite closely. So if we're describing here, that's not perfect, is it? But it follows the pattern of the environmental change. Okay, whereas the red line, it's a bit easy to see, I'm not going to go over that one. The red line is not affected as much by that environmental change. Now, the reason for that, I'm going to reiterate this. In the red line, now, community with high species diversity, it's likely that there's a greater variety of plant species. So there'll be a greater range of habitats. Each of those habitats and each of those plants perhaps provide a greater range of food sources for primary consumers. If there's more primary consumers, there can be more secondary consumers. So there's a greater range of food sources, making it more likely that some species will be able to survive that environmental change. Okay, so here's that in a bit more detail. Communities with high species diversity are less affected by environmental change than those with low species diversity. Now the reason for that is, if we look at this, what's going on there? Why can't I change this? I don't know. I can't make it any bigger. I wanted to, but never mind. If we look at this this food web here, we can see that we've got plants. Now, if you have a high diversity of plant species, that provides habitats for different primary consumers, different animals. So we've got that range of habitats and also a greater range of food. If there's an environmental change that affects one of those producers, one of those plant species, well, there'll be other plant species present in a community with high species diversity to compensate. And therefore the rest of those animals that are dependent upon those producers will be less affected. So a greater range of habitats means there's a greater range of food sources, meaning it is more likely that some species will be able to survive environmental change. Okay, good. Types of places where there's highest species diversity? Well, Amazonia or tropical rainforests, and I think in fact the rainforests in Honduras, is it? Perhaps, oh, Panama. Okay, but yeah, Central America and South America, but more generally, tropical rainforests have the highest diversity. Certainly, that's been measured. That's obviously a terrestrial habitat. Aquatic ones, well, coral reefs have the highest indexes of diversity. So, effects, therefore, of certain human activities may reduce the biodiversity in places like tropical rainforests, and those activities might include farming practices. So farming practices may include deforestation or clearance of the forest to provide more pasture for animals, and that tends to be what's happening in Amazonia. Big clearances of forest to provide grazing land for cattle. That cattle is providing meat essentially to North America, and that's why we see big areas of Amazonia and rainforest in South America. In coral reefs, well, increases in global temperatures and sea temperatures is leading to coral bleaching. And that coral bleaching, well, it kills those corals, and we can see here there's lots of different species of both soft and hard corals there, and each one provides a different habitat. Coral bleaching kills all of them. Fewer habitats, fewer food sources, a decrease in the variety of food sources, and therefore the animal diversity is reduced as well. Okay, so human impacts. Deforestation, farming. So deforestation for farming. Let's begin on farming. So farming practices might include the use of pesticides to kill pests. Now, a pest really is only a pest if it is reducing the yield of a crop. In nature, that pest may just be a herbivorous animal. To a farmer, a herbivorous animal is destroying a crop and therefore becomes a pest. So they use pesticides to prevent that. Herbicides, likewise, a herb or a plant species only becomes a weed when it is reducing the yield, the growth of crops. Okay, so farmers use pesticides and herbicides to kill pests and weeds. Farmers also remove hedgerows, less so in the UK in the last 20 years or so, but certainly in that post-war period, throughout the UK, hedgerows were removed. Now, I said this to a class a couple of years ago, and I talked about it for a few minutes before realising that people didn't know what a hedge was. But a hedge is the barrier, the border at the edge of a field. So hedgerows are used as borders, perhaps to form a boundary between two different fields. Perhaps animals are kept on one side, crops are kept on the other, and that's fine. Those hedgerows, and you can probably see from this hedgerow, are really great areas for biodiversity. So you may have lots of different species of plants and trees present in those hedgerows, and if there's lots of plants and trees, that means there are lots of habitats, so a good variety of food sources, and those food sources can support a variety of animals. Now, in the post-war period, 1945 onwards to about the 1970s, farmers were given subsidies to increase food production. And that's fine, we're coming out of the war and we're having to do a lot more food production. But to increase food production, farmers started to use larger machinery. And that larger machinery wasn't very efficient if you had all of these tiny little fields with hedgerows in between. So what we found in parts of the country, those hedgerows were removed to compensate for that larger machinery and to increase the efficiency and therefore the yields that farmers could produce to produce more food. Unfortunately, the impact of that was the loss of habitats because there were fewer of these plant species, lots of food sources, and then lots of species of particularly small mammals and birds were severely affected by that. And that hasn't really been improved even since there is less well, as those hedgerows haven't been replaced, they have in some places, but not particularly, those small mammal species and birds have their populations haven't increased. Okay, so deforestation might also be for selling wood or for building infrastructure, building roads, for expansion of conurbations, expansion of towns, etc. All of these things, all of these human impacts have the same effect. So you must say in your responses that there is a decrease in the variety of plant species. Therefore, the number and variety of habitats has decreased. There are fewer habitats, there'll be fewer sources of food, and the effect on all of that eventually is that the animal diversity will decrease. Okay, all of those things combine, meaning that the species diversity of those areas would decrease. Okay, I think that's everything for this last video. If you've got any questions, feel free to send me an email or leave them in the comment section below. Thanks a lot.